All right. Well, hello, everybody. Hope you're all doing well. There we go. So my name is Aaron Stannard. I'm one of the founders of the Akka.Net project. I'm joined here with Gregorius, who works here at Pettibridge. Gregorius, how are you doing today?
Oh, pretty good. Thank you. How about you?
No worries. I would love to have gotten a little bit more programming done so far today, but sometimes this is how the cookie crumbles. After this, hopefully, I will get a chance to do so. But yeah, that's my only beef so far. So today we're going to be covering a couple of. If I go grab our little banner here. We're going to go ahead and cover some recent Akka.Net releases first. This shouldn't take too long. And then we're going to dive into the meat of what we're going to cover today, which is talking a bit about Akka.Net 1.6 and our upcoming roadmap. Specifically, we're going to be taking a look at the serialization system for Akka.Net in the near future. So let's start by taking a look at some of the things we've done. Last week, we went ahead and did our Akka.Net application management best practices webinar, which I went ahead and I wrote a whole blog post about it and put a little YouTube clip of this up onto the website that has basically the full recording on it. I'll go ahead and post a link to that in chat for anyone who's interested. The gist of this was all mostly about don't do things like try to build a ornate, grandiose, generics-driven framework on top of Akka.Net. It's going to result mostly in pain and suffering for the companies that try to do this. And I see it a lot when I'm doing code and architecture reviews. And I offer an alternative in this webinar, which is pattern-oriented design, which is all about finding reusable patterns that are simple, immutable, and are designed to basically help you end up with skinny actors ultimately, which allows you to do things like test most of your business logic without needing Akka.Net in the middle of it. That is all well and good and generally a good practice. It's something that we're following ourselves as we're in the middle of rewriting SDK bin right now. So definitely eating our own dog food there. But I kind of went into the guts of this. Hopefully you found some value out of reading through this. And I definitely recommend taking a look at my little code sample here, which contrasts the two different approaches. Yep, the music's still playing, Gregorius. I turned it on. Let's see, Akka.Quartz.Actor 1.5.12. So, Gregorius, why don't you go ahead and shed a little bit of light on this in terms of what's the big change we added here?
This is to add a fix made by one of our contributors. It makes sure that all of the payloads are serialized by using the object serializer. It's just to make sure that serialization and deserializations are completely synchronized.
Because I think before the issue was we were always defaulting to Newtonsoft.json for some of the serialization in here, which if you're using Hyperion, which I believe this user was, would break down if things weren't in sync.
Yep.
So yeah. Yeah, I'll go ahead and turn off the music. All right. The gist of this with Akka.Quartz.Actor, look, I have written zero code in this plugin. I don't think Gregorius has either. A lot of the stuff that kind of emerged from the early days of Akka.Net, where there are a lot more contributors, all kind of working on their own ideas and everything else, is that we definitely suffered from a lack of standardization, especially when it came to serialization. Gregorius and I have spent years cleaning up all the Akka.Persistence plugins that have this problem. Akka.Quartz.Actor is no different. Also had an issue with that we've cleared up. The next stage here is probably to fix this issue, deserializing when using custom serializers. This is something else that we probably also need to work on. Basically adding support for working with the same serializer ID and manifest system that everything else does. That's something that we should really get to work on. So maybe we'll do that in the not too distant future. But that's something that we've kind of addressed in 1.5.12. Next, we've got a new release of Akka.Hosting. We had, let's see, the couple of bugs that you addressed around, I think, configuration mapping. This was for people trying to basically pass in quoted keys and that sort of stuff. But the real big fix was expanding the Akka.Remote and Akka.Cluster options. Why don't you talk about that real quickly?
Yeah. So we added support to uh, add in more advanced options to remote options. Like now we can actually declare how big of a buffer the TCP transport going to use and stuff like that. So
And these are
um,
settings that like you don't need just to kick the tires and fire up Akka.net. But once you start running production applications and you're worried about things like large messages or false positives showing up on your failure detector, these settings get tweaked all the time in production systems. We regularly recommend tweaking them in a lot of our support channel when we're working with customers that are building like large scale systems. So we just made it so now you can update the stuff directly in C# and F# and not need to use Hocon. So that's kind of
mhm.
the big change there. Let's see. Next, Akka.Healthcheck. You just pushed this, I think, yesterday.
Yep.
Pull this up. No, a couple days ago. The big change that you fixed here was a whole bunch of issues related to the Akka.Persistence health check throwing off false positives. Or sorry,
Mhm.
false negatives, technically.
Well, it's not only that, but there was a bug where if the snapshot store plugin circuit breaker was tripping, it would fail fast, and that would cause the probe actor to actually spam the log with because it will kept on trying to connect to the persistence back end. So yeah, we fixed that. It is release.
Yeah. So we've had some end user acceptance testing. They reported that it's working a lot better than it was before.
Mhm.
So if you're
Yeah.
using Akka.Healthcheck, you should and you're using the persistence health checks, I would upgrade promptly if I were you. Let's see. Um, Now let's see other changes. Akka v1.3 beta 1. This is a big one. We're still undergoing some beta testing here. I'll let Gregorius kind of explain why we're testing it and when we expect to release it. So go ahead, Gregorius.
Okay. Well, the biggest change in this release is that we're shifting our scheduler from our custom scheduler to a more, uh, I guess, .NET accepted practice by using async await, and it should cut down on the CPU use when the actor system is actually idle. Um, we're still testing it right now. We have, I think, several people trying it right now to see if it's actually as stable as it suggested in testing. And we're running an in-house stress test on it right now ourselves, just to make sure that it doesn't break any of the existing behavior that we have.
Yeah, that's right. We want the CPU utilization improvements that are offered through here. Basically, the periodic timer runs on top of the .NET thread pool. Doesn't need a dedicated
Mhm.
thread anymore. And one of the problems that we have with the hash wheel timer today is that it uses a dedicated thread, and when it's waiting between ticks, that shows up in a major way on the CPU profiler. So we're trying to help reduce some of that, but the problem is that we need to make sure that the new timer doesn't miss ticks, that it doesn't that it plays catch up properly if it's been asleep for longer than its scheduled interval, which happens pretty frequently because of how clock resolution is naturally imprecise on preemptive operating systems like Windows, most distributions of Linux, and OS X. So we're basically just kind of testing to make sure that none of the differences in behavior between the old implementation and the new one are so big that it would have an outsized impact on somebody's application. So we're trying to do our due diligence there and be thorough about it.
Mhm.
So we've been running some tests in Kubernetes. Those all looked pretty good. I think the next ones that you were planning on doing, Gregorius, they're all bare metal experiments this time, right?
Yep.
Yeah.
That is correct.
So we expect to have this released. Honestly, we could probably get it done this week. But we just, when it comes to changing a pretty major piece of infrastructure like the scheduler, we are very judicious about making sure that that is done correctly. So that's what's going on with that. And I think that's it for all of our sort of releases this week. And I'm going to go ahead and move on and talk a bit about our show and tell. Let me go and get my PowerPoint up. All right, there we go. So we're going to be talking a little bit about the Akka.net 1.6 roadmap today. Now, if you have never seen it before, I've mentioned it in our Discord and maybe in a couple of our other community stand-ups. But we're going to go ahead and kind of formally lay out some of our design goals and what we're going to try to accomplish. So let me go ahead and make that full screen. So these are our current plans for Akka.net 1.6. We plan on starting work on this in early 2024 is the current target for that. And the focus of our Akka.net 1.6 release is going to be performance. So 1.5, while there were some performance benefits, like for instance, all the dual targeting stuff we did with .NET 6 was a big part of 1.5. Our dual targeting with .NET 6 was something that we added in Akka.net 1.5. Akka.net 1.5 was mostly focused on developer experience, hence Akka.Hosting, Akka Management, Akka.Healthcheck, Akka.Persistent SQL, all that stuff. This release is focused more squarely on improving performance, trying to make Akka.net faster, more memory efficient, and basically be able to take advantage of parallelism in some places where we aren't right now. So probably the biggest change we have planned is our networking layer. Today with Akka.Remote's sort of classic networking model, it's very much built around basically a pluggable transport layer. So for instance, just a few minutes ago, I was recommending the gRPC transport that I wrote as an experiment to a customer that has to run Akka.Remote in a HTTP only environment. We can thank Cloud Foundry for that. But that's designed to be kind of a pluggable transport system that's basically just responsible for moving bytes from point A to point B. And Akka.net 1.6, the new transport layer, is not going to be pluggable, although we will still support turning on classic remoting, that just like how the JVM did. We will still support that, so customers can start upgrading to 1.6 gradually without having to take their entire application offline all in one go. So we are going to kind of introduce an upgrade path for users. But the first major thing we're going to do is introduce a reliable networking layer based off of a UDP based protocol. That'll either be Aeron, which is what the JVM uses, or maybe it'll be Quick. That depends very much on what we can get support for in terms of our run times. So that's all going to come into play here. This transport layer is going to take advantage of multiplexing much more properly than our current transport does. So this system won't be vulnerable to head of line blocking the same way the Akka.Remote currently is today. On top of that, the overall throughput should be probably an order of magnitude faster. So the max throughput I can kind of get today on Akka.Remote, which uses a single TCP connection, on this machine I'm using right now, which is a relatively new Intel architecture, I can do in the ballpark of 700,000 messages a second over a single connection. With this new system that we're developing, our target is closer to 2 to 3 million messages per second. I think that will be doable, but it will require some other work, such as the serialization system. The serialization system currently is actually the biggest outside of Akka.Remote's architecture, which doesn't allow for multiplexing. That's like a fundamental design problem with it. Aside from that, the biggest source of overhead is the serialization system today, namely because, now I'll get into some of the details, but namely because it's not super efficient with how it uses bytes. It requires multiple layers of serialization, which compounds that problem. And then on top of that, writing custom serializers that can do things more efficiently isn't something that a lot of developers do out of the box. That's something that we can potentially improve upon with the design that we're going to propose today. Next is we're taking a look at updating the actor cell and the dispatching implementation, namely rewriting the way the mailbox works in Akka.net 1.6 to natively take advantage of essentially the task scheduler. Every single mailbox invocation would essentially return a value task that gets awaited. This would allow all message processing to natively support await inside of it if you wanted to. and would also, generally speaking, allow us to potentially move away from the dedicated thread pool inside Akka.net. Instead, we would have groups of task schedulers instead. This would allow us to take advantage of the dynamism of .NET's thread pool, so that would allow for dynamic scaling of threads up and down, and should, generally speaking, improve throughput and lower CPU utilization at the same time. So that is the goal. We'll have again, these are all ideas. They have to be borne out with data and implementation and tweaking. Next is the Akka Streams Materializer for faster compilation. This is basically using the phased fusing materializer. We actually need this in order to build the network layer. So that's going to be done. And we have other changes planned too, such as some improvements to the way cluster sharding works, for instance, and probably lots of other little small optimizations that will hopefully add up to a big overall end-to-end improvement in performance. So let's talk a little bit about the current serialization system and some of the issues it has. The first is that we default to polymorphic serialization. Today, that's mostly Newtonsoft.json, but for a lot of users, that's also Hyperion. Polymorphic serialization is a useful default because it requires basically no setup on the part of the end user, which is ideal from a time to market standpoint. However, we have always, over the past, let's say 6 or 7 years, recommended that users migrate to schema-based serialization once their messaging model is pretty stable. That looks like Google protocol buffers or message pack. The reasons why we recommend this is that the primary reason is version tolerance, the ability to make changes to your wire format safely without potentially destabilizing your system, or if you're using Akka.Persistence, without bricking your old data is the reason why we do this. So the version tolerance piece here is actually kind of an important ingredient. On top of that, schema-based serialization doesn't use any metaprogramming, so it tends to be tremendously faster than what polymorphic serialization can do. Finally, schema-based serialization also happens to be significantly more secure than polymorphic serialization is. Namely, you don't have to worry about risky types being deserialized because we're not using reflection anymore to do arbitrary type instantiation. Instead, we're limited to an explicit set of types that can be instantiated based off the user's definitions. So these are the things that we've been recommending to users for years. However, there are some significant problems with the current serialization system. This is what defining a serializer looks like in Akka.net 1.5.12 today. You would go ahead and subclass the serializer with string manifest. You define a manifest. A manifest is just a constant string value that represents one discrete message handled by the serializer. So typically, we would go ahead and use some short code for kind of representing each of these different message types here. Then we have to have a big switch statement that maps all the different types that we want to serialize and converts them into a byte array. So in this case, we're converting this to a protobuf representation and then converting that to a byte array. And then on the deserialization side, we have to go ahead and parse those bytes back into a protobuf representation and then convert that back into our .NET representation of those same types. So the basic gist behind this here is that custom serialization requires a fair amount of typing today, and it's a little tedious to do. Now, do I think the fact that it's tedious is a reason not to do it? No. You would be making a very poor trade-off if you decided to say, well, I'm going to go ahead and stick with JSON.NET instead of spending 7 hours building something that's secure, fast, and version tolerant. It's just not a good trade-off. However, these are some of the examples of the protobuf mappings. Some of the other problems the serialization system has, though, are a lot more significant than just how tedious it is. A good example is that memory management is a problem with Akka.NET serialization today. Namely, that it's not clear where memory boundaries are on the deserialization pathway. So reasoning about how would I safely release this pooled byte array so I'm basically not putting a lot of pressure on the garbage collector when I'm deserializing messages. That is not something that is very easy to do in the current architecture. Next is that deserialization happens in layer. We have an outer Google protocol buffer layer, and then we have an inner envelope that rarely represents your types. And some systems, there might be as many as 2 or 3 additional inner envelopes that all get kind of globbed together here. That's, for instance, if you're using the new Akka.Delivery stuff, that's one envelope. If you're using Phobos on top of that, that's another envelope. And if you're using D-Data on top of that stuff, that's another envelope. So this can result in a lot of unnecessary and somewhat defensive copying. This is kind of a strength and a weakness of Akka.NET's design. It's a strength in that allows us to have a very modular, composed view of serialization. But it's a downside because that results in, again, unnecessary and defensive copying, and also increases the overall latency involved in deserializing a single message. And then the last issue is more of an API management and design problem, which is that when we originally designed these APIs back in 2013, excuse me. When we originally designed these APIs back in like 2013, 2014, they were all built around byte arrays because it was either that or basically array segments. And that was all that was kind of in market for .NET at the time. Now, here in 2023, 2024, we have access to things like the system.memory namespace. We have access to the memory data type, iMemory owner being another good one, spans, you name it. We can essentially redesign these APIs to try to work towards zero copy. Probably isn't possible, but at least a much smaller amount of byte copying than what we have today should be feasible with this. But trying to have end users reason about this in the design of their own serializers is a fool's errand. It's not a good use of anyone's time. And I think it would probably result in a lot more pain, agony, and debugging problems that would show up. So what's the solution to this particular design challenge inside our system? We want to have users engage in schema-based serialization, and we also want to manage memory allocation much more intelligently than we do today. And we also need to have some way of trying to detect issues with the wire format potentially. Well, the solution that we're kind of experimenting with right now is doing design time metaprogramming. So rather than maybe doing what polymorphic serialization does, which is its runtime metaprogramming, why not use something like a Roslyn code generator to identify types that need to traverse the wire and generate stable wire type IDs? This is a unique serializer ID plus a unique manifest. And then, if we can, try to enforce extend only design principles here, i.e., don't allow people to do things that could potentially compromise the wire format without letting them know they're doing that. That's not something we've implemented yet, and we're still taking a look at how feasible that is, because it kind of requires comparing the current output of the it would require comparing the previous output of the source generator against the new output. And that actually may not be super easy to do necessarily. But like I said, I'm just laying out here what our goals are, not what we've done and have exhaustively proven that we can do. We want to be able to automatically generate serializer definitions and schemas. Basically, we want to be able to write the serializer string manifest class for you using these metadata attributes, and to help keep those serializer IDs plus the manifest stable across hundreds of new versions of your software. Part of this will also involve us changing the default APIs for serializers to now support probably iMemory owner is the one I'm thinking we'll end up using, since that tends to be the most amenable to working with shared buffers in kind of like an asynchronous context, which is where we are with Akka.NET. So we might go ahead and be able to reason about all the different acquiring byte arrays and releasing them. We might be able to do that for you as part of this design. Now, one thing I should assure users like Steve, if I go ahead and pull this up, how do these serialization changes affect message pack users? Ideally, they shouldn't. You are not going to be forced to use the system here. You basically have to decorate your types with explicit attributes in order to get the serializer to go ahead and get generated for you. It's part of the idea. And we need to have an upgrade path to support existing users who've worked with their own custom serialization so far. We need to have an upgrade path that allows you to continue to use those same approaches so you don't end up losing access to, let's say, older data and Akka.Persistence, for instance. That's something that's absolutely a essential requirement for this design. So you're not going to run into any trouble there. We are also considering as part of this automating schema-based serialization. I think the example that Gregorius is going to give is using just BSON via Newtonsoft.json for it, which is essentially still polymorphic serialization. But we might do something like generate message pack or Google Protocol buffer based schemas for types in the future. Again, we haven't investigated how to do that specifically yet. We're at a much earlier stage, kind of the proof of concept for this, but that is kind of what our overarching goals are. So, upgrade path for existing users, the ability to go ahead and solve these problems without the user having to write up a whole bunch of tedious code, and taking advantage of more modern .NET memory practices for better overall performance is the goal here. So I'm going to go ahead and hide that. All right, Gregorius, are you ready for your demo?
Yes, sir.
All right. Okay, Gregorius, go ahead and show us what you've built. And this is available. I'll go ahead and drop a link to the pull request, but this is actually available right now as a PR on the main Akka.NET repo.
Mm-hmm.
All right, go ahead.
Well, as you can see, what I have right here, right now is just an empty console template. It's with just the entry point right here, the infamous main static function method, and then in here I've included some project reference, mainly Akka, and then the serializer project that I just made for the proof of concept, the generator and attribute. The attribute here is the metadata attribute that Aaron talked about just a few minutes ago. So basically, it allows you to tell the code generator that you want a certain class to be serialized, and you want Akka to generate the serializer for you. And generator itself is quite complex, so I wouldn't really look into it right now. But in essence, how it works is, let's say we want to make a simple CRUD program, and we start by modeling the commands itself. Well, we might start with a create command, and I told the generator that I would want this class to be included inside the serializer with a manifest CP. And what the code generator does is, if this is working correctly, sometimes rather, yeah, it is. Sometimes rather kind of barfed on this its new features, but what it does is it generates all of these for you. Basically the boiler code, template code that you've seen Aaron showed a few minutes ago. This is the serializer being generated basically in real time as I add in more and more classes into this, into the messages.
Yeah, there you go. You can see additional types being added to the serializer's manifests on here.
Mm-hmm. I think if you watch all of the source generator videos in YouTube right now, you would see basically the same demo being played, like it is being generated in real time and all that. But I guess the main point that we're trying to make here is that we're going to use this new feature to generate the serializer for you, so you don't have to do it yourself.
Yep. And right now we're just using BSON, which is basically not that far removed from the Newtonsoft.json stuff we do today. But with a little bit of legwork here, I think maybe it would be feasible for us to do something like synthesize protobuf models or whatever. That's probably going to require some expansion of the meta programming that we have right now. So we're not done
Hmm.
yet by any stretch of the imagination. We just kind of want to illustrate what's possible, what we're thinking, and talk a bit about why we're doing it. Get feedback from users before we start investing hundreds of hours into building this thing. I am very excited about this because I view it as kind of the next leg up for trying to make sure that Akka.net is performant and is also wire safe by default. Kind of looking at this not just from a performance point of view, but also from the point of view of trying to help keep things, trying to make sure that best practices for managing distributed systems are observed by default and have our tooling try to enforce some of that. And source generators seem like a powerful tool. One concern that has been raised by some members of our community is that Roslyn code generators don't work for F sharp. That is indeed the case, I believe. So we might have to explore some different options for being able to support F sharp users. I think there is some third party tooling out there that can maybe fill in the gaps in some of this. Either way, we're going to look into that and do the best that we can. Um, so, yeah, I think that's all that we've got for today. Gregorius, do you have anything else you want to add?
Oh, yeah. Well, the good news is that this code is actually working. Like, well, it is still using based on underneath, but the generated code actually works.
Oh, wow.
Yeah.
That's great. And by the way, didn't you also add something to automatically generate the Akka.Hosting custom serialization bindings for this too?
Not hosting. Right now, I'm still using the setup class
Oh,
and
okay.
Ogun. Yeah, but
Gotcha.
it is generating all of the helper functions.
All the
Like,
serialization bindings.
yes.
Cool. So yeah, that'd be
Hmm.
useful tool. Have the ability to go ahead and just say, hey, any serializers that were generated using Akka.its tooling, just go ahead and add those registrations. And
Hmm.
I guess we'll probably do some assembly scanning or something to figure that out. Um,
Yep.
yeah. All right. Well, hey, Gregorius, good work on the proof of concept. Appreciate that. Team members, or sorry, members of the Akka community, if you have any questions, go ahead and hit us up in the Akka Discord in the contributors room. Gregorius and I are almost always in there. Thank you again for joining us. Next month, we are going to have a speaker from the community talk about their use of Akka.net and their application. So I'm very excited about that. They are also F sharp users. So you should hear some updates about that as we get a little bit closer. But otherwise, thank you very much for your time today. We appreciate it as always, and we will see you in Discord.